lecture upon the information systems, that what is the need of information systems, and why the information systems are necessary for different type of businesses. Now, if we analyze that what is the purpose of information system, basically the information system provides us lots of facilities. For example, a manual system may be summarized with lots of efforts, but if a digital system we have in an organization, we may summarize the data very quickly. So whenever the data is summarized, it is known as, means the processed data is known as information. That's why we ask him information systems. So the definition of information systems is very much clear from the previous lectures. Then when we say that processed data is information, and now when we have the information, when we will process the information, that will be converted into the knowledge. So the second part of this lecture will be about the data mining techniques and data warehousing as well. Means the machine learning techniques and the artificial intelligence techniques will be used. So it is a brief intro. We will not go into the much more detail. So data resource management is done through the information systems. So the learning objectives of this lecture is to provide examples to illustrate each of the following concepts, such as major types of the databases, then data warehouses and data mining, then logical data elements, and then fundamental database structures and the database development. Moreover, we will see some of the concepts of data warehousing and data mining as well, at the abstract level, because in this lecture it is not possible that I will show you the data warehousing and data mining in a detail. This is a completely different discipline. If we have been offered a course that data warehousing in businesses, we may think about this, and are the data mining in businesses, or the machine learning in businesses, we may think about it as well. So what are the major types of the databases? We have to see, first of all, what is database management system. Actually, data is saved in files, for example, in the MS Excel. If it is in the form of the MS Excel, well, it is sufficient. But the second part, when we say that we have the thousands of the rows, how can we accomplish and how can we tackle such data? So actually, the data resources must be structured, organized in some of the logical manner, so that can be accessed, means retrieved, processed, and managed easily. So basic concept of the database management system is just like we have the Excel file, but we don't have the database management system. But in database management, in the database, when the management system is involved, then loads of DQL, DDL, DML, and other languages are there. These are the part of the SQL, structured query language. So they give us some sort of lots of facilities to access the data, to process the data, to manage the data very easily. And accessing the data by using the relational database management system, which in which the relational algebra means set theory has been involved. We know in class 8 set theory is very much intersection, union, and these operations are there. So same has been followed here. So in this way, we can say the data resources must be structured in some manner. So these are the fundamental data concept that what is the character? Actually, character is a data, the most basic logical data element that can be observed a single alphanumeric or other symbol represented by one bit. Actually, in the computer memory, as we have learned that bit by bit information is saved, but the character occupies one byte space. And what is the field? Actually, the field is also known as column, and combination of fields is known as row. So in MS Excel, when we see that there are some columns in database, there are some columns, but database has the different concepts, and the here if we see the relational or the other type of the database management systems have the other concept because primary key and secondary keys are discussed. So we have to just build a concept that field a grouping of related characters as a last name or a salary represents an attribute of some entity. Now, field is also known as attribute and column, and entity is known as some sort of, we can say that it is a table as we see in the MS Excel. So, general purpose application programs it is used and they perform common information processing jobs for end users. It is very much clear that it is used for the common purposes and the record a grouping of attributes that describe an entity. Actually, record is combination of fields and we can say that it is a row. Means if we have a name, F name, salary, class, like these things, if we have the related data, a grouping of attributes that describe an entity is a record. That's why we can say that a row is a record. So it is very much then the database is a collection of logically related data elements and give us lots of combinations as well because the database is logically related. So in the next lecture, we will see that what are the fundamental concepts and data concepts are being built in a more significant manner as well. So employee record and record 2, record 3 is there. Now actually these are the rows and these are the fields. SSN number fields. Now we can build a record as well. So in this way, we have this some sort of record. Think a while, give it in time that there are three type of the databases. Now in these fundamental concepts, we have to see that T Jones, salaries, SSN number, insurance fields. Now these are the basically files related to the human resource databases. So the payroll file and benefit files are there, but it may contain lots of data. It is one of the example just. And then we can see the database structure, the hierarchical structure, tree-like structure, and structure one to many parent-child relationships. Each child can have only one parent. We will see in the graphical form, and then we will discuss. And the network structure is similar to that, but it allows many relationships. A child record and more than the relational structure as well. The most widely used database model is relational database model, and through this we can say that data is represented as series of two-dimensional tables, as we have seen the previous figure. That tables are called relations. Each column is named attribute of the entity, and each row is a named instance of the activity. Now, this instance is again terminology that could be understood by us. It is instance is also a row. A row is also called instances. Means it is a record as well. Now we have to see that what are the consequences, that what are the differences between these data types and how can we say them, and what are the two-dimensional tables we have seen in that previous picture as well. Now, what are the relational operations? Select, join, project. In the select operation, we create the subset meets the criteria. Means if we ask a query, inquiry that how many, what is the maximum salary of employee in that particular type of the organization, or what is the range of the salary, and we can join record one, record two for the view purposes. And in case of the project, we create a subset for the temporary tables as well, and we can see that these are the assumptions of the data, and we can summarize the data in a more structured way. So the multidimensional structure variation of the relational model using the multidimensional structures to organize the express relationships. Now, what are these? Now here, if we see that this is the hierarchical structure, department, now project A, project, now employee is working in employee 1 and 2 in project A. Now in this there are direct combinations, and in the relational structure we have the department and we have the employee. Now we can see that this is the relationship, this is the primary key and this is the foreign key, and we can find that employee 1 is in the department A and employee 2 is also in the department A, and employee 3 is in the department B. So if we draw here that employee 3 belongs to uh, employee 3 belongs to project P. So these are the fundamental concepts, and this is a cube. This is taken basic concepts to build the understanding about the data warehousing. A sample data cube is before you. Now these are the aggregations, summarized data. Now how it is summarized, we will see in the schemes. So VCR, TV, and PC are the products. First quarter, second quarter, these are the dates, and then again, this is the summarization into the USA, Canada, Mexico, and lots of. So this is a basically dice before us, a cube. We can scroll it by see the data from the multi-dimensional ways. So in data warehousing, the all dimensions could be seen. Now here we can see it has been scrolled TV VCR, February annual budget, whatever in the January. Now this is the timeline here, and here we can see that east, west, north, south, whatever the actual, what was the budget, and into the quarters we can scroll the six dimensions as well. So this is the multi-dimensional, and we can think that it gives us lots of varieties as well. So the object-oriented structure combining the data of the interest and the process that act that data into the structure called an object. Now, when we say about the object, now object is a place, is a some sort of the table. It is an object. If it is an object, now what could be the method through the data is to be saved? What are the restrictions? What are the rules and regulations by following that data is to be saved? So it is encapsulated, means it is embedded in that and defined very well in that particular object. And inheritance means the upper class functions could be tried. If we want to say that class A, user A, or employee A, or the department A, employee 1 is belonging to department A, and 2 is also belonging, but 3 is also, means we can inherit the above classes through the programming by using these things. And another thing is polymorphism, which is not written here, means one object could be used with many shapes. So evaluation of the database structure have grown more complex as the needs have changed and grown complexity. And finally, it has touched to the big data. And what is the big data? We have seen in the previous lecture that speed, volume, variety was there, and by using these, we can see. So this was a little bit about the database development. Now this is what are the actual responsibilities of a database administrator. It controls the development and administration of the database. It defines the data definition language used to specify the contents, relationships, structures of the database. For example, what would be database will contain, and what is to be, how the business logic will be converted. It is to be described by the database administrator. So when it will describe, it will create a data dictionary directly containing the metadata, which is known as data about the data, as we have discussed. For example, we have a dictionary in that we can see the synonyms of that data, and we can easily understand that what are the synonyms, antonyms of that particular type of the data and how it can be utilized. So all the definition could be defined into the metadata. So data planning and database design is also responsibility of the database administrator. So data modeling, entity relationship and diagrams, logical models, and data itself must be done before choosing the database model. And the database schemes also to be defined by the database administrator, that it is the physical internal view of the system, and this is the sub logical external view of the system. Now we have to understand that what are these. But the database development, if we see the database life cycle, it is also done by the followed by database administrator. That data planning develops a model process and then defines the business documentation, then requirement specification, and then the description, and then conceptual design is done there, and the physical data models are there in that particular type. Logical design is also there, and we have to see them. So entity relationship diagrams, this is one of the example, that this is one, this is many, means purchase order has relation one to many with purchase items, and products have one to many orders, supplies have many to many products are have the. So this data is stored, backup is restored into the data warehouses. Now in that data warehouses, but we have to say that it is a separate database which is stored into the database. Now here the duplicate data is allowed, redundant data is allowed, and the data is to be stored as a backup as well, and for the organization as well. So data are organizational resource that must be managed by another resource. For example, if there is a disaster, If we have the backup of the data, we can restore the data. And if we are working on the online transactional processing, means operational database, we can do anything, but offline we can do. So types of the database used, for example, we have the distributed database systems or the network database, network based. So data warehouse is there and users is there and external and internal databases and data marts are saved into that particular type of the database, data warehouses. Now operational database means store detailed data support business processes. Operations means it is operational, but when it becomes passive and its backup is still stored into the data warehouses. Same likely if we have a vehicle, if we have some sort of the materials, some sort of the products, we always save them into the warehouses. But in case when we store the data, then we can say that this has been stored into the data warehouses because it is a data. So distributed databases, many organizations distribute their databases over the multiple locations, replication, complex processes, updating the data and duplication simplified, and many of the updating data is there. So external databases outside the firm, free from the base and hypermedia database are there. Hypermedia means, for example, we have the YouTube and other like these applications, and we have to follow them. So data warehouses store data extracted from other databases, means derived from the operational databases, and it becomes secondary data set. And what are the data marts subset of the data warehouses, focusing on the single topic. For example, on the salary, on the product, on the time, on a particular type of the country. These are the data marts. So that can be defined by using the metadata. And data mining is the analyzation, as you have seen the summarization. Warehouse reveal the hidden patterns of the data trends, means how much, which product, how much sold in which country, at what time. Means we can expect that this product can be sold next time, can be sold next time in that particular type of the region. We can, if we have a canteen, we can see that, or we have a tuck shop. What is the trend of the customers in the summer and the winter? We have to keep this in mind, and we can buy and sell these products as per the specification that we use. What, for example, in a person, if we analyze the data in the morning, someone has scammed and it is purchasing the eggs, definitely there is a possibility it will go for the milk, and then for the slices, then for the other items. So we have to keep these things in the morning in a sequence that he can choose as per its need very easily. But what is the at the evening and what is at the night? So we have to focus upon these businesses, that how we have to arrange the data. So this could be done through the data mining techniques. So operational external databases are there, data acquisition is there, data management is there, and metadata dictionary is there, querying report is there. So this is the basic concepts of the data warehouse that we have discussed, but this is a graphical. So what is the role of the database administrator? What is the role of warehouses, and what is the OLTP? What is the database, and what is the data warehouse? We have to see these are the subsets, ERPs having, and these are the data marts from different perspectives, as we have seen. Now, in the data mining extracts the business knowledge from the data warehouses. From the very start, we say that data is processed data is known as information, but when the information is process through the data mining techniques, it may give us a knowledge. And actually, this knowledge is also known as decision support system, and by which we can understand that what is the pattern of the use customers in the morning time and other times, and how we have to generate the data. So in that we have to select the data, target it, then we have to transact data, select data, and then data mining techniques are there, and then we can find the business knowledge. So LTP, we can see the user side are mostly IT professionals, and OLAP. On the OLAP, data warehousing operations are performed, and this is the operational database. Means this is the secondary data, this is the primary data. So functions day-to-day decision support system is there, DB application oriented, and this is subject oriented, and this is the historical data as we have discussed in detail. So we have some differences as well. So what are the star schema, snowflake schema, and fact consolidation? Actually, these are the schemas which have the dimensions and measures while modeling the data warehouses. Star schema, a fact table in the middle is connected to a set of the dimensions, and then the Snowflake is little refinement of that particular, but the fact consolidation has the one then more than one dimension table. Now this is the example of a star schema. We'll write in the there. This is the aggregation, summarization, and here we can see these measures, and these are the products through which this summarization has been made. So fact table is there. Now, little bit refinement, supplier key. Now the supplier details, city has been also derived, and lots of refinement can be done also. But here we can see that we have the multiple fact tables, shipping fact table and the sales fact table. And these are the measures, and here these are the measures. It can be refined more. So data warehouse, and we can say that traditional file processing data was stored in independent files without regard the needs of the data, just like MS Excel. Load cus 1 to 3 into the very beginning of the computing, and then the processing of file was converted into the databases, and the database seek to solve the problems. Data redundancy means duplicate data is not allowed, the same data is kept more than one locations, and database seek control, not reduce redundancy. This lead to the data inconsistency where the irrelevant data has scam and the same multiple locations, but values are different. That's why if the values are different, then it is not redundant. It is not duplicate. So lack of the data integration, these are the problems of the database, and then the data dependency problems are there in which the data is tightly coupled, and the data integrity is some of the standardization that are to be defined very carefully by the database administrator as well. And the consolidated data separate from the into the database accessible in multiple programs, and database management system is a collection of programs create, maintain, use, retrieve data, and as we have seen, this is some sort of first slide that we have discussed, and the database maintenance is very much organizational database need to be updated continuously. Means this is the work of actually database administrator, and the application development. This is also the responsibility of database man administrator, that it facilitated by the data manipulation language provided by the DBMS. So database interrogation query asks database query allows us ad hoc requests of the database as we have discussed. And one more thing which is very much crucial in this, that Boolean logic, three logic operators and or not. For example, A and B items are present, then it is true. But if I say that A or B are there, either one of them means it is true. But when I say A and B are not in the set, then we can say that it is true, otherwise, it is false. So, graphical and nature queries have the methods of the SQL structured query languages. So, thank you very much for your active participation. I am highly grateful to you for your time listening and participation. Hope you will